Good day everyone, my name is Jozef Elises and I will be discussing my design project, which is entitled Cryptography, an application of matrix mathematics in the real world. So first of all, let us define what is cryptography. So in the most simplest of terms, cryptography is the practice and the study of the techniques for secure communication. In terms of messaging or sending a message, a cryptography is taking a message and turning it into something that cannot be easily understood. So think of it this way. You have a message over here and then you want to encrypt that with a key, with a unique key that only you and the receiver know. The receiver knows the unique key and then will use then that key and then it will turn back into the original message for the receiver to read. So just a little fun fact, did you know that Julius Caesar himself was very well known for using a type of cipher, which is taking a letter and taking the letter that is 3 letters forward of it, and that will be the encrypted message. This was very well popularized by Julius Caesar, therefore it is now called the Caesar cipher. Next off, let's discuss the cryptograph with matrices. So let's say I have a simple message here that I want to send to my friend. First, what I will do is I will get the corresponding position of that letter in the alphabet. For example, for A is 1 and then so on and so on. For spaces, I will put 0. That in itself is a pretty simple message to decode. So what we will do is we will use matrix mathematics to encrypt that message and then use a specific key to encrypt that message and then use that same key to decrypt again. The formula for encryption, which is your key matrix times your message. So for my key matrix, I used a 2x2 matrix, and the message would be written like this: the first element, which is the first letter, and then below that first element is the second letter, and then so on and so on. And then I just put a dash here to signify that this will be a space, and then the corresponding element for that would be 0. So to encrypt this message, you then have to multiply the key by the message, or the numbers corresponding to the letters of the alphabet in that message. So this is how you will multiply that matrix. So to multiply two matrices, we have to make sure that the number of columns of the first matrix is equal to the number of rows of the second matrix. So in this case, we have a 2x2 matrix multiplied by a 2x5 matrix. We can multiply this because the number of columns of the first matrix, which is our key for the cryptograph, has 2 columns, 1, 2. And then for the second matrix, we have the message, which has a 2x5 matrix, which has 2 rows, 1, 2. So that means we can multiply these two. So to multiply these matrices, we need to first multiply the rows of the first matrix to the columns of the second one. So for that, we can make our new matrix. We can have 2 times 8 plus 4 times 1. 4 times 1. Next, we have for the bottom one, we have 8 times 8 plus 6 times 1. So we're gonna do that for all of the other matrices, and then when we're done, we're gonna have a final answer of 20, 70, 66, 144, 32, 48, 66, 224, 40, 150. So that will be our encoded message. Encoded or encrypted message. So now we've multiplied the matrix and we have our encrypted message over here, which has the elements 20, 70, 66, 144, 32, 48, 66, 224, 40, and 150. That will be our encrypted message that we'll be sending to our receiver. So then what now will the receiver do so that he will understand this message? He or she will understand this message and read what is inside. So we have our encrypted message matrix here. To get our decoded message back, we first must know how to get the inverse of our key matrix. So this is how you do that. How to get an inverse of a matrix? So in our case, our key matrix is a 2 by 2 matrix with the elements 2, 4, 8, and 6. So what we need to do is find the inverse of that, which is the matrix raised to -1. So to get that, we use the formula 1 over the determinant of our matrix A, which is our key matrix, times C11, C21, C12, C22. And then that would be equal to 1 over A times D minus B times C, this matrix, D, negative B, negative C, A. Substituting our values, we have 1 all over A times D, which is 2 times 6, minus 4 times 8, which is our B times C, multiplied by D, which is 6, negative B, which is negative 4, negative C, which is negative 8, and 2, which is our A. So to get the final answer would be our new matrix, our inverse key matrix, which is negative 3 over 10, 1 over 5, 2 over 5, and negative 1/10. That is our inverse key that we'll be using to decrypt our message. So now we know how to get the inverse of a matrix, in our case a 2 by 2 matrix, which is our key, and then now we want to decode that message, the encrypted message that our sender has given to us. So basically what we do is get the inverse of the key matrix and then multiply that by the encrypted message. So doing so will yield us this original message, 81 9 12 08 25 4 18 and 1 is the message Hail Hydra. So now what can we do to computerize this process? So let's head over onto MATLAB to create a simple code that will encrypt and then another code that will decrypt our message. Okay, so here we are in MATLAB. I've stated the key. After that, we have the input, B equals input. So that will assign the input, the matrix input, into the variable B. If ever there will be a space, or in case that it will not be an even matrix, substitute that with 0. So after we've inputted our message matrix, then we will be encrypting it. The key matrix A times the message matrix B. Multiplying the key to the message will give us an encrypted message. The encrypted message is shown below, display C. So it will then display our new matrix. Now let's try to run this program. Input the message. So let's say I wanna input the message dig. Dig has 3 letters, therefore I should have a 0 at the end. So next we'll put enter, and after that it will give us the encrypted message. I have written another code which is called decryption.m. This code will basically decrypt the encrypted message from a while ago. After we have the input, we will then have this equation, A raised to -1, which is just the inverse of A, times B, which is our encrypted message matrix. After that, we will have an fprintf, the decrypted message is shown below, display matrix C. So now let's test out our decryption code. So input the encrypted message as a matrix. From a while ago, we've received our message, which was the encrypted matrix, which is this one, 44 14 86 56. Done. The decrypted message is shown below. Our new matrix is 4970. We now have our original message. 4, the 4th letter of the alphabet is D, the 9th letter of the alphabet is I, and the 7th letter of the alphabet is G. And then 0, just to even out the matrix. So now we have our original message, which was DIG dig. So what is the significance of cryptography in our lives? First of all, cryptography can be used as privacy for messaging. What we did a while ago, taking a message, encrypting it, and then the receiver will decrypt it, and then that will be the message. So this can also apply to computer science, in data privacy or information privacy. In this day and age, everything is on the internet. Your personal information can be on the internet. So what encryption can do is that it will encrypt your data so that just not anybody can see your data and use that data to their advantage.